Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Quick note before we begin, the Finding Genius Foundation, as part of the Finding Genius podcast, has recently completed a book about understanding viruses. So the creation of this book was to interview 100 virologists, ask them a lot of deep, difficult questions, take the most difficult questions, and then re-interview the top 25 or so and ask them the hardest questions I could think of. And we compiled that all into a book. So you'll see question and 4 or 5 experts' answers. Question, 4 or 5 experts' answers. There's about 30 questions in the book. I think it's a great read for the layperson and for the researcher. It talks about a lot of speculation in the world of viruses, such as are they alive or not, and why is it important? Why do viruses go latent or hidden or ineffective or sit in a person or an animal or another creature for weeks, months, years, and then suddenly become virulent and affect that person? So there's a lot of really provocative questions in the book. It's now on Amazon. So if you go to Amazon and type in Finding Genius, you'll see the book on viruses. It's also on Kindle. The Audible version is in production and should be ready in approximately a month. But if you want to go and order it now, you can do so again by going to Amazon or Kindle, or go to findinggeniusfoundation.org and go to publications. There's an opportunity as well to get the transcripts of all the interviews and to hear the original interviews themselves. If we put them all together, the book would be about 1,000 pages, but we condensed them down to make it juicy and concise and tight and very interesting. So I hope you'll check out the book. We're now working on one about cancer, but this is going to be our goal is 3 times a year to come out with these masterclass books that I think will inspire new scientific research, and I hope you'll check it out. Thank you.
Hello, this is Richard Jacobs with the Finding Genius podcast, now part of the Finding Genius Foundation. Today I have Terry Hrubec. She's a professor of anatomy and embryology at East Via College of Osteopathic Medicine. So we're going to talk about household chemicals that can lead to birth defects. I believe they used a mouse model, but we'll get into that. So, Terry, thanks for coming.
Sure.
So, what is your research about? Are you trying to test the effects of chemicals on people, or what's it about?
So, I started research on development, and that includes anything from the fertilized egg on up to the adult. And in the middle of one of my studies, looking at the effects of a pharmaceutical, my control mice suddenly developed the birth defect I was studying. And so the control mice are supposed to be normal. So on further reflection and sort of hunting around for what was going on, I found that they changed the disinfectant that they used in the mouse room, and that's what was causing the birth defects. So from that point on, I then switched to studying what is this common disinfectant that almost everybody has in their house? How and why is it causing birth defects that I'm seeing in the mice? So
how many of the mice had the birth defect, and how serious was the defect?
Prior to the change in disinfectant, none of my control mice had the birth defect. So it's very, very rare in an unexposed normal mouse. So after I found out the exposure, about 10% of the baby mice had the defect. The specific defect is a neural tube defect. This is formed when the nervous system is first developing. In people, it causes anencephaly and spina bifida. And in humans, it's one of the most common birth defects that children can be born with.
Is it possible to fluorescently label or somehow label or tag cells in a developing embryo so that you can see as it develops which cells came from where and literally the whole progression of the different structures that form?
Absolutely. And that's done all the time to track different cell populations as they move around the embryo. There are also a number of stains that are specific for a given cell type, and you can stain those cells and again watch them as they migrate around the embryo as it develops. It's really cool.
Yeah, what's been noticed? Have they done this in people or just in mice? And if so, when you get to the 4 or 8 cell stage and then from beyond, what happens to the original cell that started the whole thing? Does it disappear or does it stay?
So in people, we do not do these types of studies in in human embryos. That would be unethical. So most of the work is done using a chicken model because you can manipulate the egg easier than egg inside of a mouse, because the egg is, external. You put it in a little dish and watch it develop. A lot of the work is also done with mice because there's a number of specific gene knockout models that you can test the effect of individual genes on development. So,
like in a mouse, though, the first, sperm and egg combined zygote, what happens to it as the cells divide and proliferate? Does it stay or does it disappear? Like, has anyone looked to see what happens to it, the first cell?
Right. So it divides initially, but over time, by the time you go from that fertilized egg to an adult, that cell is going to have died and been replaced by a newer cell.
Oh, it doesn't stay? That would be a really cool and unusual story if it did. It's too bad, your inner child in a way.
All from that one individual cell. No, all cells have a turnover rate. That's what we have stem cells for, to repopulate the cells that we have in the adult. And so your original...
Okay. Oh, I just wonder if anyone, again, I know we'll get back to the chemicals in just a second, but I just wonder if there's a name for when that first cell dies, and does it always happen at a particular stage of development, or is it just, however many times it's divided, it reaches its Hayflick limit and that's it?
So once you get past the 8-cell stage, the cells start to differentiate, and they're fated at that point to become a certain tissue type, certain cell type within that tissue. Past that 8-cell stage, each of those cells will have a different fate, and they'll have a different longevity and a different ability to stay or to go away.
So does that first cell always differentiate in the same way, or does it differentiate differently?
When you get that first cell is going to divide into 8 individual ones. Of those 8, they're each going to do different things. So it's hard to say what that first cell is, right? Because the material is divided up equally between those 8 cells that form.
I just wonder if it's special at all, or if it's just, again, the original one that now is divided multiple times. It still has, I guess perhaps some quality of the other cells that's different, perhaps not. Maybe it's just another cell. That's what I was asking and wondering, is it anything special about it, or it just joins the regime of other cells and looks normal?
Right. I mean, that's a great question, but it should just become like all the other cells in the body as it differentiates and goes further down its path to become what it's going to be as an adult cell.
Okay. All right, very good. So back to the mice and the new cleaner. Can you name the cleaner that you used before and what the new one was that caused the birth defect?
I can mention what the one that they changed to, the new one. It's a cleaner that contains 2 chemicals. One we abbreviate as BAC, BAC, and the other one is DDEC. They have long chemical names. I can give them to you if you want, but they're really a tongue twister. They're labeled on cleaners as BAC or alkyl quaternary ammonias. So if you look at your labels, that's what you will see. They're common in a number of household cleaners. They're used commercially in public spaces to disinfect public spaces. They're used in the food production industry to clean all of the equipment and surfaces in food preparation. And they're also used extensively in hospitals. What's interesting to note is that half of the chemicals approved to disinfectants approved for use against COVID, half of them are these quaternary ammonia compounds. So it's very likely when you see everybody in stores spraying and wiping down everything, and the increased use in hospitals, is very likely that that's a quaternary ammonia compound.
So this could potentially be very bad news for people, especially with all the heightened overcleaning.
Right. Exactly. That's our concern.
How much of an exposure, how much of a body burden did the mice have? Was it excessive, or did it only take a little bit amount of these new chemicals to cause the defects?
So again, that's a bit of a complicated answer. It is not known very little is known about these chemicals. It's not known how they get into the body. So in our studies, we started off feeding the mice. Well, it turns out that the chemical is not absorbed very well from the gut. It is absorbed into the body, but it appears that the primary route of exposure is through inhalation. In our initial study, when we first found the defect, the mice were just housed in the room where they were using the disinfectant. So we weren't actively exposing them. They were just in the environment where the cleaner was used.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
That means that they are somehow ingesting or inhaling the cleaner from normal use. So that's, again, a concern for people who are using this as a normal cleaning product, either in their work or at home. So that exposure was sufficient in the mice to cause the birth defects that we saw.
So depending on profession, if you're a hair care person or a nail tech, or if you work in a place where you have to clean constantly, how much would your exposure be versus background normal as a customer?
That hasn't been measured. We just had a study published that measured body levels in humans for the first time. So we measured the QAC, that's a group of chemicals for both the disinfectants. We measured QAC levels in people. 80% of the individuals in our study contain disinfectant in their blood. The whole population, we haven't screened a large enough percentage of the population to know what the average body burden. We need to do.
Are you going to be doing follow-up studies, or is anyone doing that, or is this raising alarm, or how's it being treated? When you or other people have reported on this possibility of birth defects.
I would love to continue this work. I would love to do a larger epidemiologic study to determine what's the average level of exposure in the population. I would like to know how long the chemical persists in the body. We just don't know. I think it's starting to raise alarm for people. A lot of people have noticed my work and inquired about it. The human study was just published about a week ago, and so it's going to take a while for that information to get out and raise concerns.
Have you got any feedback? Is it peer reviewed, or is it preprint? What's been the feedback so far?
It's been peer reviewed, and a lot of the comments are very positive along the lines of, it's great that you're doing this work. This work has needed to be done for a long time. So I think it's going to be very positively viewed and very helpful to the regulators who are trying to determine how to regulate this particular.
The mice, did you look at any other effects? So they had birth defects, like you said, about 10% of them, but did you look at their microbiome to see if that was disrupted, or like what else correlated with the use of this chemical? What was observed?
Right. So we've done a number of studies. One was to characterize the birth defects. We also looked at reproduction, because in addition to the birth defects, we noticed that the mice were having fewer babies. So a baby mouse is called a pup. And so we were able to show a decrease in the number of pups that were born to mice. We also were able to show that the disinfectants affected both the mothers and the fathers. So the sperm counts were decreased and the sperm motility was decreased. And then in females, they had fewer ovulation and fewer implantation. So it affected both males and females. We've also done studies to look at immune function, and we've showed that the function of a number of the immune cells is altered by exposure to the disinfectant. These are all in mice. We've done some cell culture studies and have shown similar changes in the immune cell function with cells in culture.
Well, how do you characterize the changes in immune cell function? Was it upregulated? Was it downregulated? What happened?
So we measured cytokines. Cytokines broadly can be classified into pro-inflammatory and anti-inflammatory. If you upregulate a pro-inflammatory cytokine, you'll have greater inflammation. If you upregulate an anti-inflammatory cytokine, you'll have decreased inflammation. What we saw is that our pro-inflammatory cytokines were upregulated, so they produced more inflammation. Our anti-inflammatory cytokines was depressed. So the anti-inflammatory cytokines work to downregulate, to dampen the inflammation that occurs.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
If you deregulate that, if you downregulate that, it means that you're not controlling the inflammation as much. And so you'll end up with even greater inflammation. It's like a double-edged sword.
Can you quantify how much of an exposure the mice had versus what a person would get? I don't know if you look at it in terms of body weight or length of exposure or concentration of the chemicals. Like, how do you characterize and then extrapolate to people what might be happening to them?
So that you can't directly go from a mouse to a human. We're totally different animals. And the way we handle the chemical once it's in our body is different. What we know about the exposure, let me back up a bit. We also don't know how long it lasts in the body. So once you take it in, how long until the body gets rid of it. So you can measure what's in the blood or what's in the tissue, but until you know how quickly it passes through the body, that only gives you a snapshot just in one point of time to let you know what the level is at that point. I can tell you that mice that were in the room that were exposed to just the use of the disinfectants, they have levels in their body that are equivalent to the mice that we fed the disinfectant. So the exposure, the internal exposure is going to be the same, whether the mice are just in the room or whether they're also fed the disinfectant. In our human study, we found that the levels in some of the people was equivalent to what we were seeing in the mice. And those levels were ones that we were seeing the health effects in the mice from. I don't know if that level will be harmful in people. We were not able to test whether that exposure was contributed to any disease states, but we did see the same changes to inflammatory markers that we did in our mice.
With the human studies, did you, I guess obviously unethically, it would be unethical to deliberately expose people to it, but if they're being exposed anyway, what conditions were the subjects in? Like, how are they exposed to these chemicals? What industry were they in? What was the mechanism of exposure in the studies?
Right. We just don't know. We know even less about human exposure than we do about the exposure in rodents. We don't know how it gets into the body. We don't know how long it lasts. And we don't know what tissues it goes to. So sometimes chemicals have a liking for a particular tissue, and they'll migrate to that tissue and stay. Other chemicals will just be passed out through the body very rapidly. So lots of studies need to be conducted to look at this to see, how long does that exposure last and what effects it's going to be having on our health.
Well, what studies do you want to do in the near term? What needs to be done in your opinion?
I would like to see a large epidemiologic study, like I mentioned.
Oh, but like what would some of the parameters of the study be? What would it look like? Could you give a few details?
Right. So you would measure both the body level of the disinfectant. You could look at occupations and see if there's a correlation between occupation and body level. You could then tie that to a number of markers of disease, for example, the inflammatory cytokines that we measured. And then you could also look at any diseases that those individuals have to try to find an association between occupation, exposure, and health outcomes. So in our study, we didn't measure any health outcomes. We just looked at markers that indicate affect the immune system and affect the mitochondrial function. But we didn't look at how those effects translate to any specific disease. So you'd need a much larger study to be able to look and see if there is a link between exposure and a particular disease.
Well, what about, going earlier on? And again, like, let's say looking at hairdressers or looking at, maids in hotels, people that are, for 8 hours a day exposed to a lot of these chemicals, and then looking in their blood and, seeing the levels of the chemicals. Would that at least be a good start to the study? Or really it's only the epidemiological part that's important?
You need both. So you need to identify what occupations cause exposure And then you need to do the larger studies to determine if that exposure is related to any particular disease. We also need a study to look at what's called the toxicokinetics, and that evaluates how the chemicals get into the body, what happens to them when they're in the body, and then how the body clears those chemicals. And so that gives you a profile and lets you know, are we looking at exposures that happened a month ago? Are we looking at exposures that happened an hour ago? So you can measure what's in the blood, but until you know how quickly it's cleared from the blood, it doesn't tell you, you can't relate it back to any exposure that you had previously.
Well, what's the approval process for these kind of chemicals? And is there data that the FDA has or other governing bodies that tell you the toxicological effects?
These chemicals are regulated as a pesticide primarily by the EPA because they are used as a food additive, as a preservative on a number of foods. They are also regulated by the FDA. The process for any chemical evaluation is quite different than a pharmaceutical. So pharmaceuticals go through very extensive testings to show that they're not harmful and they're efficacious. For chemicals, the testing, some testing does occur, but it's very rudimentary compared to the pharmaceutical industry. So they look at general overall toxicity. They do reproduction. They do look at reproduction and development. But the endpoints that they measure are primarily a decrease in weight. So they're using that weight loss as an indication of toxicity. All of the things we've measured in our mice, the effect that we've seen, happen without a weight loss. So the safety testing that was done didn't measure the endpoints that we're seeing now that are indicative of harm in the mice.
Is it a difficult approval process or is it pretty simple? Because again, these chemicals are in the presence of people a lot. I mean, was this looked at, or again, is it just the process doesn't really have much scrutiny to it?
It was evaluated. They do a risk assessment, and that's available through the EPA. You can look at the risk assessment. And as I said, they do these studies to look at what they call acute toxicity. That's the amount of what happens if you are exposed to a large amount at a single point in time. And they also look at toxicity over a 60-day to 90-day period. But again, they were looking at weight loss as their primary indicator of toxicity. So yes, that goes through an approval process. The EPA takes that information. They look at how humans might be exposed to it, and then they correlate that to any mention of human disease or condition that might be associated with it. So with these disinfectants, there's a known association with asthma and what they call contact dermatitis. So you get a skin irritation if you get it on your hands. So that's well documented. That's listed in the risk assessment. And they are primarily looking at those being caused by irritation, plain irritation. The chemical is a little bit caustic, and it can irritate your skin and it can irritate your lungs to cause the asthma. So again, they didn't look at other aspects of the toxicity like we have with our studies.
I mean, this is literally like a surface analysis. It doesn't seem to go deep. I mean, for most chemicals that people deal with, does anyone have an idea if this is quote unquote enough, or is it cursory?
So in general, chemicals are assumed to be safe unless proven otherwise. So that's the general thought. They go through very rudimentary safety testing before they're put on the market. And part of the reason for this is that there's a huge number of new chemicals being produced every day. There's an entity called the Chemical Abstract Service, and they register each new chemical as it's being produced. They register 4,000 new chemicals every day. So if you're creating 4,000 new chemicals every day, there's no way that they can all be safety tested before they're put into products that we use and are exposed to. Now, that's not saying that all chemicals are bad.
Right.
We live our life based on these chemicals, and some are vitally important. I think we just need to look at safety concerns a little more thoroughly.
Well, okay, so you have your plan specifically for these quaternary ammonium compounds. Do you have the funding for it, or is this something you got to raise money for? And how long will it take an epidemiological study to be done?
So all science is done through funding, and we've been working on extramural grants and also smaller intramural grants funded by the local institutions or entities that have an interest in studying environmental chemicals. The problem that I've run into is that everyone assumes, not everyone, most people assume that these chemicals are safe. They've been around since the 1940s. And the main pushback that I get from people is, well, if they were harmful, we would have seen the effects by now. And
the past year, though, there's been how much has the usage of these chemicals gone up? Like 10x, 100x, the exposure?
Oh, I think it's like 40 times more. They haven't measured exposure yet. Okay, so they're looking at increase in sales, and they've also looked at, you can measure the exposure in the home because it binds to dust particles, and so you can measure the amount in the dust particles, and that level has increased dramatically since the pandemic started.
Yeah, so anyone that criticizes and says, oh, they're safe, it's fine, we've been using it for 70 years, well, not in this context, not at these levels, not even close. So the dose makes the poison. This is like a totally different regime, a totally different potential outcome.
Right, and that's a big concern. The other thing is that these chemicals were around for so long, but their use only increased to pre-pandemic levels in the late 1990s, when we had the other epidemic outbreaks, the SARS and the swine flu epidemics that we had. And that's when the general public got more conscious of disinfection and trying to mitigate these other viral diseases. And since that time, the use of the quaternary disinfectants has increased. This increase in use has coincided with the increase in obesity, the increase in diabetes, the increase in autoimmune diseases, and then other neurologic behavioral diseases such as autism and ADHD. So these are all diseases that have an inflammatory component. They have a neural developmental component. And I have coworkers who have shown that the quaternary ammonias inhibit mitochondrial function. So all these diseases also have a mitochondrial component to them as well. So just because they both increased over the same time doesn't mean that there's a cause and effect, but it means that we should certainly look for a cause and effect because we may be seeing the effect of exposure and we just don't know it.
Is anyone looking at the localized microbes that'll be on a given surface before and after cleaning? And now after relentless cleaning, what happens? Because I would think, the microbes are not just going away, they'll develop resistance. New ones will come in that are resistant. So the localized profile of microbes on any given surface people touch will change.
Right. So that's a big concern. And it's been a concern for a number of years. They know that microbes are getting resistant to the quaternary ammonias. And the worry with that is that once they get resistant to the quaternary ammonias, they're able to sort of transfer that resistance to antibiotics. So if a bacteria is resistant to the quaternary ammonias, it's much easier for them to become resistant to antibiotics. And antibiotic resistance is a huge problem in the world. The World Health Organization lists it as one of the most critical factors affecting health and medicine in the world today. Is if we are resistant to those antibiotics, it's going to be very hard to fight off a number of these common diseases that we get in infection.
Are there any particular groups that are committed to studying every aspect of these compounds, or is it just one here, one there, like what you're doing? Is it an organized effort?
It has been a one here, one there. We have just started, about a month ago. A number of us started getting together to try to promote a greater awareness of the potential problems of exposure to these compounds, both in the health effects, but also the antimicrobial resistance that you mentioned. And so, we're going to see where this group can take it. But, we mainly want increased awareness that these very common compounds may be harmful.
Well, very good. Terry, what's the best place for people to find out more about your work?
My papers are all available free of access. They're open access. So you can Google my name and you'll get a number of my papers on the quaternary ammonia compounds. There are also, if you look at the EPA, they have information about the chemicals, but again, that's going to be on the risk assessment, which showed very little harm and little risk to people. But there is information there. And there are other groups that are working on quaternary ammonia compound toxicity. And if you just Google for quaternary ammonia compounds, you'll pull up a whole list of researchers who have been working on this.
Okay, very good. Well, thanks for coming on the podcast. And it's a super important issue. And I really appreciate you being here.
Well, thanks for having me.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.